All right, here we go. Day three. Kind of exciting. Day 3 notes. Okay, what we're going to be talking today about is the unit circle and maybe how we can use that unit circle to help us with our reference angles and our reference triangles and our angle measures and some of the trig functions, okay? So, by the way, all of this stuff can be found at all these videos can be found at very neatly organized at nkinfinity.com. Just look underneath New York State teachers and videos. My name is Mr. Krause, but some people like to call me Mr. Key. All right, so the unit circle drawn below or over here. By the way, hit that subscribe button, will you, on the bottom for me? That would really help me out. Miss Newman and I love that. Makes our channel rise up, getting the search features better, and maybe we can help some more people out. At any rate, the unit circle drawn on the left over there, where theta is the point theta. I think I meant to say angle theta. Angle theta is a positive angle drawn with which intersects the circle at point AB. So here's my angle, positive angle, and it intersects at AB. We use the unit circle to help extend our basic definition of the 6 trigonometric functions. Well, let's think about things. We've been using the Pythagorean theorem, x squared plus y squared equals 1 all the time. Let's talk about, make sure we understand this. This is the unit circle. There's a few things that are very important. First thing we understand is, well, I said 1 here. Now, you probably don't know why it's 1 until I get to the radius. So our center is 0, 0, and our radius for this circle, because it's called the unit circle, is a radius of 1. So when I do this Pythagorean theorem, and I work within this triangle right here, that radius is 1. Or in other words, the hypotenuse is always going to be 1. Well, instead of using x and y here, one of the things we can talk about is this length here. You know, A and B is sort of abstract for some of you. What if I said this was the point 3, 4? You'd say, oh, I came out 3 and up 4. That means this length here would be 3 and this length here would be 4. Now that's kind of concrete, and I think you guys can understand that. But I didn't come out 3, 4. I came out AB. So this length right here is A. I came over A. And this length here, or this distance here, is B. I went to the right A and up B units, which is why we're at the point AB. So instead of using x squared plus y squared, I could also do a squared plus b squared equals 1 squared, which is just 1. Well, what is the cosine of this angle? Well, remember, let's go back to this right triangle. First thing here, there's my theta. Let me label this sucker. Hypotenuse, opposite, and adjacent. And didn't we say this was A, this was A, and this was B, the length? All right, so what is the cosine of the angle? Well, cosine of theta is equal to, caught another hippie, caught another horse, adjacent over hypotenuse. Well, what is my adjacent side? Well, my adjacent side here is just A. So it's A over 1 or just A. Now that's going to become important, and it goes with something I talked about in my last video, and we'll see it again here. What is the sine of the angle? Let's see. Sine of theta is equal to opposite over hypotenuse, and my opposite in this case is B, so that would be B over 1 or just B. Now, if you remember correctly yesterday, and this only works on the unit circle, and that is the cosine is equal to the x coordinate. Now remember, yesterday when I was talking about, and I said, and we're talking about where things are positive and where things are negative, and I said, listen, I want you to remember cosine is positive where x is positive. Sine is positive where y is positive. Well, when we're working with the unit circle, we can even take that a step further and say that cosine is equal to whatever the x coordinate is. Sine is equal to the y coordinate. And tangent, well, tangent is equal to opposite over adjacent, which in this case is b over a, or the y value over the x value. Now, when we start to do trig identities, just a little foreshadowing, we're going to find out that tangent of theta, now what goes with the y value? Oh, sine, is equal to sine theta over cosine theta. And this will become something later on to remember, and one of the things you're going to have to commit to memory when we start doing trig identities. But for now, we're just going to remember it as y over x. So we're going to use this picture. We're going to use this picture that we have above, and we're going to figure out what we know about the unit circle. So sine of 0. Now remember, it's equal to the y coordinate. Well, if I go out to the y coordinate at 0 degrees, let's see, maybe I'll put this stuff in here. 0, 1. Up here, excuse me, let me try that again. 1, 0. And that's at 0 degrees. At 90 degrees, we've got 0, 1. Oh, and by the way, hypotenuse is equal to 1. Oh, we talked about that already. This one out here at 180 degrees is negative 1, 0. And at 270 degrees, we've got 0, negative 1. So remember, if I go through, this is cosine, this is sine. This is cosine, this is sine. This is cosine, this is sine. And this is cosine, this is sine. So I just ask for the sine of 0 degrees. Well, the sine of 0 degrees is the y coordinate at 0 degrees. So that would be 0. So sine of 0 is equal to 0. The sine of 90, now that's straight up, is equal to the y value at 90 degrees. That's 1. The sine of 180 equals 0. The sine of 270, negative 1. And again, if you follow that along, 0, 1, negative 1, 0, 1, 0, negative 1. Now, cosine of 0 is right here. It's the x value. That's 1. The cosine of 90 is 0. Cosine of 180 is negative 1. The cosine of 270 is 0 again. Now, this one's a little bit trickier. Tangent. Now, tangent is going to be our, remember, y over x, sine over cosine. So really, we just have to divide these. 0 divided by 1 is 0. 1 divided by 0 is undefined, and that is true. The tangent of 90 is undefined. This is 0 over negative 1. That's just 0 again. And this is negative 1 over 0, and that's undefined. Okay. So fill in the important features of that unit. So let me pause for a second, and I'll be right back. So we've learned a few things now. We've got to take together, let's see if we can put together all of the stuff we're talking about. Now, this is the unit circle. So let's see if I can put all the important features on this graph, and I'll do that. All students take calculus, sine. This is just everything, or all. Tangent, cosine. That's where cosine and secant are positive. This is where tangent and cotangent are positive. This is where sine and cosecant are positive, and everything's positive here. My length of my radius is 1, so that makes this 0. Excuse me, I did it again. 1, 0. That makes this 0, 1. That makes this negative 1, 0. That makes this 0, negative 1. All right, which functions are positive in angle quadrant 2? So let's go to quadrant 2. Oh, sine is positive. Sine goes with cosecant. Which trigonometric functions are positive in quadrant 4? Oh, cosine. Cosine goes with secant. Secant and cosine. In which quadrant is theta lie if tangent is, now I don't understand this, less than 0 thing, so I'm going to say tangent is negative, or in other words, not positive. And cosecant, now I don't understand anything about cosecant, but I know that cosecant goes with, and its reciprocal function is sine. So wherever cosecant is, sine is. So sine is greater than 0, or sine is positive. Sorry about that. So I'm looking where tangent is not positive. Let me put some big stars. Tangent is not positive here, and tangent is not positive here. And I'm also looking where sine is positive. Everything's positive here, and sine is positive here. So this is the big winner. It gets 2 stars. So we are in quadrant 2. All right, let's try this again. Get rid of my stars. If sine is negative, that's what this means. Sine is negative. Let me go up there and put stars where sine's negative. Remember, sine goes with y, so down here the y's are negative, so sine is negative. I don't understand cotangent. Okay, so but I know it goes, and it's a reciprocal function of tangent, and tangent is positive. Tangent is positive in quadrant 1, and tangent is positive in quadrant 2. So we are going to terminate in quadrant 3. It's the big winner of this circle. So what you're looking for is which quadrant meets these needs, where these things are positive. The next one says, in which quadrant are both tangent and cosecant negative? I don't understand cosecant. So cosecant goes with sine. So where is sine negative and tangent negatives? All right, so let me star where tangent is negative. Tangent is negative here, and tangent is negative here. Remember, tangent's positive here and here. Where is sine negative? Sine is negative here, sine is negative here. There's my big winner, quadrant 4. And the final one says, now this is kind of tricky. It says sine is, it's trying to get you to think too much. I don't care about this. Sine is negative. Well, sine is negative and tangent is negative. So where is sine negative and tangent negative? Well, isn't that the exact same thing I just did here? Tangent negative, sine negative, quadrant 4. So reference angles and the unit circle, all of your best friends. Okay, so if we've got 30, 60, 90, we are going to use reference angles or our reference triangles, the ones we've talked about. I'm going to draw those right below here. I thought I had them right below here. Where are they? Oh, they went to the other page. And then if I use 0, 90, 180, I'm going to use the unit circle for those. And I've got a little trick for this stuff too that's going to come up. So remember, oh, I should have put the angles in here. Opposite the 1 is the 30. There's the 60. Remember, these are both 45 and 45. And over here, all students take calculus, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Get used to that. And don't forget, and this is the big one right here, cosine of theta is the x. Sine of theta is going to be the y value. All right, let me pause. So it's party time. Oh yeah, baby. It's reference triangle and unit circle. Party time. What? We're partying in math? Not really. No. All right, so here's what we got here. This shows me that special right triangle I was working with. And in conjunction with the unit circle. Now, the unit circle is a little bit bigger than I wanted it to be in this drawing. I'm not an artiste. Okay, so you have to kind of imagine. So we dealted with the triangle 2 square root of 2 square root of 2. That's what we talked about. I showed you how that worked here. But remember, all 45, 45, 90 right triangles are proportional, are similar. They're just dilations of each other. Therefore, all the sides are going to be in the same proportion. Okay? So, if I take this radius and I take it and I make it the unit circle radius, which is just 1, what have I taken? I've said, okay, I have divided it by 2. Well, if I divide the hypotenuse by 2, I've got to divide each of the sides by 2 in order to get to the unit circle. And therefore, they are proportional. Now, why in the world am I telling you that? Well, I'm telling you that because in the unit circle, this point here would be the square root of 2 over 2, the square root of 2 over 2. Now, we've talked about this a couple times ago, a couple days now. What is the cosine of 45 degrees? We've said it is adjacent over hypotenuse, square root of 2 over 2. Well, if I'm looking at the unit circle, there it is, square root of 2 over 2. The sine, remember, sine is the y value, square root of 2 over 2. So in the unit circle, the x value is the cosine and the y value is the sine. But to go from our reference triangle to our unit circle, we have to divide everything by 2. And that's where this trick I'm about to show you is going to come into play. And I hope it comes up nice on here. Otherwise, I may have to reprint this. Oh, it came up on the next page. Okay, it's called the hand trick. We'll get to it. All right, so find the exact value of the cosine function given by the angle drawn in the reference triangle below. All right, so 210. So this is 1, right? Now, if I remember correctly, this, by the way, my reference angle is 30. Opposite the 30 is 1. Opposite the 60 is the square root of 3. So let's talk about the coordinates of this point. Remember, because we're in the unit circle, remember this was our diagram. Doggone it, sorry about that. This was our diagram. 2, 1, square root of 3. But because this is the unit circle, I got to divide this by 2. I got to divide this by 2, and I got to divide this by 2. So what are the coordinates of this point? We went over to the left, the square root of 3 over 2, but it's negative because we're in the third quadrant, square root of 3 over 2. And we went down 1/2. Well, that's also negative. So what is the cosine of 30 degrees? The cosine of 210 degrees? The cosine of 210 degrees is the square root of negative square root of 3 over 2. What is the sine of 210 degrees? It is negative 1/2. Let's talk about 315. 315 is right here. Again, I don't care about that. What I want to talk about is this reference angle. And this reference angle is 45 degrees. So in a 45, 45, 90 right triangle, we do 2, square root of 2, square root of 2, but to dilate it to the unit circle, we have to divide everything by 2. This is where that hand trick is going to come really handy for you. So the coordinates of this point are positive square root of 2 over 2. That's the x value. The y value is down, so that's negative square root of 2 over 2. So I ask you this. What is the cosine? Oh, in this case, what's the tangent of 315? Well, the tangent of 315 is equal to, in this case, negative square root of 2 over 2 divided by negative or positive square root of 2 over 2, and so that's equal to negative 1. This would be the cosine of 315 degrees. This would be the sine of 315 degrees. Sine of 120. All right, 120 is right about there. That would be 120 degrees. We don't want to talk about 120 degrees. We want to talk about the reference angle. And the reference angle is right here, 60 degrees. All right, so let's see. If that's 60, that makes this 30. Opposite, this is 2. Opposite to 30 is 1. Opposite to 60 is the square root of 3. But we need to make this into a unit circle, so we divide by 2, and divide by 2. So the coordinates of this point are negative 1/2, excuse me, negative 1/2, positive square root of 3 over 2. Because notice we went this way, that's negative, and then up, that's positive. So what is sine? Sine is the y value. It's the positive square root of 3 over 2. Okay, kids, so what I did was I recorded that entire video. I ripped it. I rendered it. I uploaded it, and then I'm like, I don't like that very much. So I came back and I decided, let's talk about this hand trick again, because what I did was I messed up the hand trick. And the hand trick is really going to help you. It's just a simple trick to try to remember what the values of those coordinates are. And it's actually fantastic. It's really, really good. All right? So we're going to use our left hand. Now, I'm going to try to show you like this, but what I got here, what I decided to do is I decided to add hands all over the place. So you're going to see on the next page, because I'm going to change the notes, that there's hands everywhere. Left hand. It's your left hand. You could use your right hand, but the left hand's better to use. So what we're going to use is left hand. And the cool thing is you always got your hand with you. Okay, so always. So if for some reason, and I don't mean to be mean, but if for some reason you don't, you can always just use your right hand, just turn it towards yourself, okay? Otherwise, you got to have your left hand facing you, left hand facing your face, okay? All right, so here's how it works. Our thumb is going to represent 0 degrees. Our pointer finger is going to represent 30 degrees, then 45 degrees, and then 60 degrees, and then our pinky is going to represent 90 degrees. Now, this is a really cool way to remember these things. All right, so let's check this out. You're going to fold down the finger. Now, this is the most important thing. You're going to fold down the finger that represents the reference angle of what we're talking about. So you're going to still have to be able to find reference angles. That's key to all of this stuff. Key. Your hand is now an ordered pair. Now, what I mean by ordered pair is we have an X. The finger, I was just about to draw the finger, and I figured y'all be mad at me. So the finger represents the comma, and then Y. Now, if you remember correctly, cosine is the X, sine is the Y, and the finger that you put down is going to be the comma. Now, bear with me, you're going to understand this, because I'm going to drill it into your head for the next 10 minutes. So pay attention. But now square root both sides and divide by 2. Right? Remember when we talked about the circle, the unit circle, the first we talked about 2 is the hypotenuse. And then I'm like, okay, when we get to the unit circle, everything has to be divided by 2 to scale it down to the unit circle. We want to scale everything down to that unit circle because that makes our denominator 1, which makes finding the sine and cosine much, much easier, okay? So the x-coordinate represents the cosine, I've already said that, and the y-coordinate represents the sine. So let's see how this works. Let's say I wanted to talk about the sine of 60 degrees. All right, so 60 degrees is the ring finger. So if you had your hand in front of you, you'd put the ring finger down. But I'm going to just do it this way. There's the ring finger. So that's the comma. So what's on the left here? I've got 1. 1 finger. Remember, we got to divide by 2. And on the right, I got 3 fingers. And I got to divide by 2. Now, what did it say? Take the square root of both fingers. Well, the square root of 1 is just 1, and the square root of 3, well, that's the square root of 3. So what is the sine of 60? Well, you do have to remember this, kids. The sine is the y value. So the sine of 60 is the square root of 3 over 2. Let's try another one. And then we're just going to get to the next page. Let's try another one. Let's try we'll do two more. We'll do the cosine of 45 degrees. All right, 45 degrees is the middle finger. No, you can't say to somebody, I'm going to 45 degree you, because that doesn't work, okay? We don't do that in math. So we take down this. So I got 2 fingers here, and I got 2 fingers here. Don't email me and send me a comment that says, a thumb is not a finger, Mr. Krause. Shut up. Okay, remember, what we're going to do is we're going to take those fingers. Remember, we still got to divide by 2. Every time you're going to divide by 2. But these numbers go in top, and you have to remember to take the square root of them. Oh, look at that. 45 degrees is the cosine of 45 degrees is the square root of 2 over 2. Now, okay, that was weird. Now let's talk about a weird one. Let's talk about a weird one. How about the tangent of 90 degrees? Oh, okay. 90 degrees. That's the pinky finger. Tangent of 90 degrees. All right, so. Oh, I didn't want to do tangent right now. I meant sine of 90 degrees. We're going to talk about a weird one. Sine of 90 degrees. All right, so the sine of 90 degrees, let's see. There's 4 fingers on this side, so I guess I'll put a 4 over here. Remember, we got to divide by 2. And, we got to take the square root of it. And on this side, there are no fingers. We can divide by 2. Okay. Well, what is the square root of 4? That's 2. And what is 2 divided by 2? Oh, that whole thing is just 1? So really, this is 0, 1. And, you know this point is 0, 1, don't you? And the y coordinate is the sine. Sine of 90 degrees is 1. So sine will always be, as you're looking at your hand, sine will always be on the right side, cosine will be on the left side. That's the way it is. X is on the left, y is on the right. All right. What about tangent? Tangent's a little bit more of a crazy beast. Tangent, you'll have to remember that tangent of your angle, theta, is equal to y over, that's not a v, it's supposed to be a y over x. So when we're doing tangent, we're not going to worry about the dividing by 2. So this is going to be a little bit funky for you. Let's say I want to do the tangent of, you're going to still do the square root, but we're going to get rid of the divided by 2. The tangent of 30 degrees. All right, so 30 degrees, you put down your pointer finger. And you come over here. And again, when we do tangent, we're not going to worry about the dividing by 2. What we're going to do is we're going to say, okay, there's 3, so that's the square root of 3. And there's 1. So the tangent is y over x. 1 over the square root of 3. Which you can't leave like that. You got to rationalize the square root of 3 over 3. And you get the square root of 3 divided by 3. Maybe that was a little bit funky. Let's practice on the next couple of pages, and you'll see how this works. And I think you're going to like it. If you don't like it, good luck memorizing. All right. I'll be right back. All right, kids, let's get rocking and rolling on this baby. Let's see what we got. We got 0 degrees. 0 degrees is the thumb. So we'll get rid of the 0 degrees. Now, anytime you're talking about quadrantal angles, 0, 90, 180, 360, those ones are going to be a little bit, they're always going to be 0 or 1 or 1 or 0, right? They're always going to be that. So let's do this. We got 4 fingers. Square root of 4 is 2. That's 1. And there's no fingers over here. That's 0. The sine is the y value, so the sine of 0 is 0 degrees. Now, this next one's a little funkier. I think I've changed my mind slightly on this one. So 90 degrees, or 270, is down here, 270 degrees. That means it has a reference angle of 90 degrees. So we'll get rid of the pinky. 90 degrees. So there's 0 to the left. If there's 0 to the left, then 1 has to go on the right. Now, it's straight down, so it's negative 1. So what is the cotangent of 270? Now, wait a second. Let me remember this. Tangent is y over x. So cotangent then is going to be x over y, which in this case is 0 over negative 1, which is just 0. Okay? So the quadrantal angles we're going to do slightly differently. Let's go. We have 270 again. We just did 270. So that's there. That's this pinky. And we figured out that was 0, negative 1. The y value is sine, so it's negative 1. See how fast this goes? 180. All right, so 180 is over here, right? It's 180 degrees. So it has a reference angle of 0. So I've got 4 fingers on the left. Remember, this is the square root of 4 over 2, which is just 1. So that's going to be 1, comma, 0. Now, be careful with signs, kids. You still have to be careful with signs. We're over here on the left side. The x values are negative over there. So you have to be very, very careful with that. The x values are negative. So the cosine is the x value, and it's negative 1. Maybe what I'll do is 2 and then go over there and do 2. Maybe I'll do 3 and then go over and do 3. Let me do 3. Tangent of 90 degrees. Okay, 90 degrees is here. The x value is 0. The y value is the square root of 4 over 2, which is just 2 over 2, which is just 1. 0, 1. Now, tangent is y over x, which is 1 over 0. Since we cannot divide by 0, this is undefined. Let's try cosine of 0. Get rid of this. Again, it's a quadrantal angle, so I've got 4 on the left. That's going to give me the 1. On the right, I got 0, 1, 0. Cosine is the x value. It's 1. Now, if I'm going too fast, pause this and try it on your own. 180 has a reference angle of 0. We already did 180. It has a reference angle of 0. We also know, since we've already done 180, that this is 4 on the left, which is the square root of 4 over 2, which is just 1. But it's on the left side, so it's negative 1 and 0. Now, cotangent is, remember, tangent is y over x. So cotangent is x over y. So in this case, it's negative 1 over 0. When you can't divide by 0, it's undefined. All right, let's come over here. 360. Now remember, 360 is over here, right? It went all the way around. Well, that has a reference angle of 0. All right. 4 on the left, that gives us our 1. 0 on the right, 1, 0. And it is over here, so it is positive 1, 0. Cotangent is x over y. So this is 1 over 0. Once again, we have undefined. Sine of 90. Get rid of the pinky. So let's see what we got. If we get rid of the pinky, I've got 0 on the left. I've got this 4 on the right, but by now you should realize this is the square root of 4 over 2, which is just 1. Sine is the y value, so it's 1. 270. It's down here again, 270. Right? Reference angle of 90 degrees. So 90 degrees, we get rid of our pinky. We already know it's 0, 1, but we're down here. So it's 0, negative 1. Tangent is y over x. Negative 1 over 0, undefined. All right, a couple more quadrantal angles, and then we'll get to the real cool stuff. Cosine of 270. 270 is straight down. We know that's 90 degrees. 0 on the left. We've now figured out 1's going to be on the right. 270 is straight down, so that's negative. It's got to be a negative. Cosine is the x value, 0. Cotangent of 270. Well, again, we just talked about 270 has got a reference angle of 90 degrees. We know it's 0, -1 now. Cotangent is x over y. 0 over -1. 0. We'll come back to sine of 30. Let's finish these quadrantal angles. 90 degrees. 0 on the left, 1 on the right. Cotangent is x over y, so this is just 0. Cosine of 90. Wow, I got 90 right here, so I might as well just use this one. It's the x value, 0. All right, so let's start some cooler stuff. Sine of 30 degrees. Let's go 30 degrees. 30 degrees is the pointer finger. Get rid of that. I've got 3 on the left, so that's the square root of 3. Don't forget we have to divide by 2. 1 on the right, 1 over 2. Sine is the y value, 1/2. I can't tell you how much easier this is than just having to memorize these things. And eventually you're going to. Eventually you'll commit them to memory. But for now, this is going to be a great little trick for you. Square root 45 is the middle finger. So on this one, you know that both of these are 2's. So they're both square root of 2's over 2's, so the square root of 2's over 2's. As soon as you start seeing all the 45's, you know it's going to be square root of 2 over 2, unless it's tangent. So square root of 2 over 2. 240 degrees. Now that's a little bit trickier. All right, so you got to figure out where this is. First thing I got to do is figure out, okay, I'm 240 degrees. How far past 180 did I get? You still have to figure out the reference angle. Oh, it's 60. So really what we're talking about is 60 degrees. 60 degrees is the ring finger. We'll get rid of the ring finger. On the left, I see 1. Now, that's really the square root of 1, but that's just 1 over 2. Off to the right here, I see 3 fingers, so that's the square root of 3 over 2. Now, be careful. You have to still remember which quadrant you're in. It's not good enough. This is a nice little trick, but you got to remember which quadrant you're in. We're in the third quadrant. Everything's negative, or x and y are both negative in the third quadrant. So this, I want cotangent. Oh, wait a second now. Here's how it's going to work with cotangent and tangent. I don't really need the divide by 2. Now, so I'm going to go through this once with you. It's really x over y, which is really -1/2 over negative square root of 3 over 2. Now, in order to solve this, what you'll end up doing is multiplying by the reciprocal. So this will go, I'm going to end up multiplying by, if you divide by a fraction, you multiply by a reciprocal. So watch what happens to the 2's. So anytime you're dealing with cotangent and tangent, we don't need the 2's. It's just -1 over negative radical 3. It's just going to be the fingers, x over y. So this is really 1 over radical 3 multiplied by radical 3 over radical 3. And so it's really radical 3 over 3. So anytime we deal with tangent and we're dealing with the inside angles, we're not going to need the 2's. All right, so that's going to be kind of tricky for you. All right, let's go back to cosine of 60. 60 degrees is the ring finger. I got to get rid of that pen, it's too big. All right, so 1, square root of 1 is 1, 1/2. 3, square root of 3 over 2. Now, which quadrant? First quadrant, so everything's positive. Cosine is the x value. 315. Now, anytime it ends in a 5, there's like a 90% chance it's a 45-degree reference angle, especially if I'm asking you for the exact value. It's like a 99% chance it's 45 degrees, but you should test it. I'm down here, 315. How far away am I from 360? Remember, it's either 0 or 360 or 180. You don't mess with the y-axis. And so yes, I'm 45 degrees away. So really what we're talking about is 45. So 2 fingers, square root of 2 over 2. 2 fingers, square root of 2 over 2. And wait a second, we're in this quadrant down here, and sine, or the y values are negative down there. Well, in this case, it really didn't matter, because I only want the x value, which is the square root of 2 over 2. All right, tangent of 210. This one's going to be a little tricky. I've got to get my head by on this one. 210. I got to first figure out the reference angle. And then remember, tangent, we're not going to need those 2's. 210. So my reference angle is 30 degrees. So 30 degrees, I get rid of the pointer. I'm still going to do this math the same way. The square root of 3 over 2, 1/2, right? And now I got to think, okay, I'm in the third quadrant. Everything's negative. But wait a second. All students take tangents, positive down here. And I would remember that. X. Remember, tangent is y over x. So in this case, it's going to be positive because you're dividing two negatives. So I don't need these 2's. They're going to eventually cancel out anyway. So really what I have is -1 over negative radical 3, which they just cancel. So I end up with radical 3 over 3. All right. Yes! Woo! I know, that was really loud. I apologize. Okay, do you know this is going to be 45 degrees? Yes, of course you do. You should test it, though. I'm in this quadrant. It also tells you about the signs because it tells you which quadrant we're in. Yes, this is 45 degrees. So 45 degrees, middle finger. Oh, now we're doing cosecant. Careful, kids. Cosecant. All right, so square root of 2 over 2. Square root of 2 over 2. I got to figure out which one is negative. We're in the second quadrant, so the x values are negative. Let me put that negative right there. Now, cosecant, because we don't like you, goes with sine. It is the reciprocal function of sine. Right? Remember the c and the s go together? So I need the y value. All right, square root of 2 over 2. But remember, I have to take the reciprocal of this. So it's 2 over radical 2. And if I simplify that, I get multiplied by square root of 2 over square root of 2. I get 2 square root of 2 over 2, which is just the square root of 2. Now, at some point, you'll probably memorize those. The cosecant and secant, they're the ones that are going to be a wee bit trickier. All right. -120. Are you kidding me? Why are you doing this to me? Who cares? You just go, it's 120, but we go backwards. So how far is 120 from 180? Remember, we always go to the x-axis. Always, always, always the x-axis. So I'm 60 degrees away. So my reference angle is 60. Get rid of the pointer. Now I'm in the third quadrant, so right now I know everything's negative. Negative, negative. All right. 1 over 2, square root of 3 over 2, and I want the sine. Oh, sine is the y value, negative square root of 3 over 2. Oh my gosh, this is easy. All right, 300. Trust me when I tell you, go over it, practice it, because this is a lot much more simpler than things I've done in the past. All right, 300 degrees. I'm 60 degrees away, right? I'm 60 degrees away from 360. 60 is the ring finger. So we'll get rid of the ring finger. And I got 1 over 2 and radical 3 over 2. Now, let's see. We're in the fourth quadrant. We're down here in the fourth quadrant, and the y's are negative down here. All right. So I know my answer is going to be negative. But remember, I don't need the 2's when I'm dealing with these. So it's negative radical 3y over the x, which is 1. So this is just negative radical 3. All right, we got 3 left. 405. Come on, Nooms. She picked these angles. It's all her fault. There's 360. And then I keep going. Let's see, 360. And I'm just going to go 45 more. So this is really just 45 degrees. Oh, that's not hard. That's not hard. That's the middle finger. Anytime you got the middle finger, they're both the same. The square root of 2 over 2, square root of 2 over 2. So this is, and we're in the first quadrant, square root of 2 over 2. 210 degrees. And how far away is 210 from 180? Oh, they're 30 degrees. 30 degrees. Pointer finger. So I get the square root of 3 over 2. I get 1/2. Whoa! What quadrant are we in? Oh yeah, we're in the third quadrant. Sine and cosine, or x and y, are both negative. All right, I want cosine. I only want the y value, or the x value. Negative radical 3 over 2. My big head might have been in the way of that one. Let's do cotangent of 150. We're going to end on a hard one. How far is 150 from 180? Oh, 30 again. 30 is the pointer finger. I just did this. Square root of 3 over 2. 1/2. Now we got to think. Let's see. We're in the second quadrant. So that's over in this area. And I know the x's are negative over here. Cotangent. Let's see. Tangent, remind myself, tangent is y over x. So cotangent is x over y. So again, I don't need these. So it's negative radical 3 over 1, which is just negative radical 3. Drop my mic. Drop the pen. I hope you guys liked that. I hope it was okay for you. Yeah, not bad. I like that one. So, that's it, kids. That's all she wrote. That's it. I dropped the mic. Okay, I hope you guys enjoyed it. Hit the subscribe button, hit the like button, hit the thumbs up button, and share this with your friends. Let them know. All right. Later, kids.